KIMI K3, 2.8 trillion parameters. DeepSeek V4 Flash, 284 billion. Both open weights, both free to download, both sitting on the internet right now, waiting for you to try them. So, which one runs on your machine? Almost everyone answers that by glancing at the two numbers and assuming the smaller one is the easy one. That assumption is about to meet actual arithmetic, and I'd like you to keep hold of it because what happens to it about halfway through this video is the reason I made it. Here's what we're doing. Both models side by side in specifications rather than adjectives. A 2-minute detour on the one architectural idea that makes either of them make sense. Get this, and half the confusing model announcements you read suddenly become legible. Then the memory arithmetic run honestly on both. Then the full tier walk, 4 GB to 192, plus a 60-second method for finding exactly where your machine lands. Then the part I actually want you here for. There is a documented technique that breaks the memory rule, with a measured number attached from a source I pulled myself this week, and it does something to this comparison that I did not expect when I started researching it. I'll show you the number and I'll show you what it costs, because it is not free. After that, free access compared, and I went and searched a live routing registry for both models and found something that decisively separates them and that I have not seen mentioned in any coverage. Then the head-to-head verdict, and the honest limits. Standards note, same as always, no benchmark scores in this video, no pricing figures, architecture, arithmetic, and access. 3 things I verified myself before recording, with sources in the description so you can check my work. Let's go. The Two Contenders. KIMI K3, 2.8 trillion total parameters, the largest open weights model released to date. It's an extremely sparse mixture of experts. 16 experts active out of 896. Do that division, under 2% of the model is awake at any moment. The published weights land around 594 GB in their native format, licensed under a modified MIT. DeepSeek V4 Flash, 284 billion total, roughly 13 billion active, MIT licensed, a 1 million token context window. And Flash is the positioning. This is the efficient, high-throughput member of its family, not the maximum capability one. Now look at what those two sparsity ratios actually mean, because this is the crux of the entire video. K3 is radically sparse, a colossal body of knowledge with a tiny sliver firing per token. V4 Flash is efficiently sparse, around 13 billion of 284 billion, which is roughly 1 in 22. Both are clever, but K3's ratio is in a different category, and hold that thought because it's the reason the bigger model turns out to be the more streamable one. One more honest note on K3 before we go further, because it's a real decision factor and it isn't a hardware one. Independent measurement has put K3's hallucination rate around 51%, noticeably higher than several frontier alternatives. That's reported rather than something I measured, but it matters. A model being enormous and a model being reliable are separate questions. And if you're choosing between these two for real work, that belongs in the comparison alongside the gigabytes. Why sparsity is the whole story. A 2-minute detour that makes everything else obvious. If mixture of experts is new to you, this is the concept that makes both of these models make sense, and it's worth the detour. Older models were des, every parameter fired for every single token. A 70 billion model did 70 billion multiplications per token. Brutal, simple, and it meant total size and running cost were the same number. Modern large models split that up. The network contains many specialized subnetworks experts, and for each token, a small router picks a handful. The rest sit idle. That produces 2 different numbers doing 2 different jobs, and confusing them is the single most common mistake in this whole field. Total parameters govern memory. Everything has to be reachable, because you can't predict which expert the router will want next. Active parameters govern speed and cost. Only the chosen experts compute. That's your tokens per second and your electricity bill. So when you read 2.8 trillion parameters, that is a memory statement. When you read 16 experts active, that's a speed statement. They are not interchangeable, and almost every confused take about these models comes from treating them as if they were. Here's the intuition I keep coming back to. Think of a dense model as a single enormous expert who has read everything and thinks about all of it, all the time. Think of a sparse MOE as an enormous library with a very good librarian. The building is vast, but for any given question, the librarian fetches 3 books. The building size determines the rent. The 3 books determine how long the answer takes. And now the question this video turns on. If the librarian only ever fetches 3 books, does the whole building have to be in the room with you? Conventionally, yes, because you don't know which 3 until the question arrives, and going to get them is slow. Hold that slow because in 12 minutes it becomes the entire trade. The memory rule applied honestly. Standard rule from our hardware guide. At 4-bit quantization, the quality sweet spot, a model needs roughly half its parameter count in gigabytes, plus overhead. V4 Flash, 284 billion halved is about 142 gigabytes. K3, 2.8 trillion halved. is about 1.4 terabytes, 1400 gigabytes. And that is the honest headline of the conventional approach. There is no consumer machine on Earth where those numbers work. Not a top specification Mac Studio, not a dual 490 rig. We're not in expensive territory. We're in you'd be building a small server territory for the smaller of the two, and data center for the larger. So let's walk the tiers properly, so you know exactly where you stand. The tier walk, 4 gigabytes to 192. 4 to 8 gigabytes. Conventionally, neither model, not remotely. You're 35 times short of V4 Flash and hundreds of times short of K3. This is the tier where a 7 to 8 billion parameter model is your comfortable daily driver. And honestly, modern small models at that size are good. That's not a consolation prize. 12 to 16 gigabytes. Still neither. Comfortable home. The 12 to 14 billion class. 24 gigabytes. A 3090, a 4090, the enthusiast tier. Neither model. You're roughly 6 times short of V4 Flash. What this tier is excellent at is the 27 to 32 billion class, and I'd argue that's the best value per dollar point in local AI right now. 48 gigabytes, dual cards, or a high memory Mac. Still short of V4 Flash by about 3 times. K3 isn't in the conversation. 64 to 96 gigabytes, getting closer to V4 Flash but not there. Aggressive quantization might change that arithmetic at a quality cost you'd need to evaluate for yourself. 128 gigabytes, serious workstation. Top specification Mac Studio, multi-GPU build, V4 Flash becomes possible here, depending on your quantization and how much context you want. This is the maybe carefully tier for it. K3, still no. 192 gigabytes and up, V4 Flash. Comfortable, and now that 13 billion active count pays off enormously, big model knowledge at small model speed. K3, still no, even here, you're 7 times short of the conventional requirement. That's the honest conventional answer, and I want to state it plainly. On the standard approach, V4 Flash is a workstation tier model and K3 is not a consumer model at all. No amount of enthusiasm changes 1400 gigabytes. Except there's a technique that does. Before the twist, how to find your own number in 60 seconds. Quick practical interlude, because 128 gigabytes only means something if you know what you have. If you're on a desktop with a graphics card, the number that matters is your card's VRAM, not your system RAM. On Windows, Task Manager's Performance tab shows dedicated GPU memory. On Linux, the standard NVIDIA tool reports it in its header. That figure is your tier and system RAM does not rescue you, spilling into it collapses your speed. If you're on an Apple Silicon Mac, you're in the pleasant situation. Because memory is unified, the GPU can address system RAM. Your total RAM roughly is your budget, minus what the operating system needs. That's why high memory Macs punch far above their price in this specific arena, and it's why they show up in every one of these tier discussions. If you have no discrete GPU, you're in the CPU and system RAM tier. Smaller models work fine and are genuinely useful. The two models in this video are not conventionally reachable and streaming is your only door. 2 practical rules while you're checking. Leave headroom, roughly a couple of gigabytes for the operating system, more on a machine you're also working on. And remember, context costs memory too. A long context window consumes additional memory on top of the weights, which is precisely why the maybe carefully tier is maybe and careful. A model that fits with a short context can fail at a long one. Now the twist. The twist. The rule has a documented exception and it favors the bigger model. Here's what I verified this week, and it genuinely surprised me. There's an open source project called AirLLM, Apache 2.0, been going for a while, and I pulled its documentation directly before recording. Its central claim is that it dramatically reduces inference memory by streaming, and it publishes specific figures. 70 billion models on a single 4 gigabyte card, 405 billion llama on 8 gigabytes, a 671 billion DeepSeek on about 12, a 235 billion QN on around 3, and the one from last month, which is the reason this video exists, KIMI K3, all 2.8 trillion parameters, running on a single card in 3.72 gigabytes of VRAM. Their documentation states that as measured end-to-end on one professional card. Read that against the tier walk we just did. 1400 gigabytes by the conventional rule, under 4 by this one. And here's the crucial part. The technique explicitly does not involve quantization, distillation, or pruning. It's not a shrunken model. It's not a student model trained on outputs. It is the actual weights. And the reason it works is exactly the sparsity we discussed at the top. Per expert streaming loads, only the experts a token actually routes to. The rest stay on disk until they're needed. Now connect the two halves of this video. K3 has 16 of 896 experts active. That is the most extreme sparsity ratio in this comparison by a wide margin, which means at any given moment, the fraction of the model that must be resident is tiny. The very thing that makes K3 absurd to hold in memory is what makes it exceptional to stream. That's the answer to the paradox in the opening. The 2.8 trillion model streams better than the 284 billion one because it's proportionally emptier at any instant, bigger and easier for this one technique. What it actually costs, the honest trade. Now the part the excited videos will skip, and it's the reason I'm not telling you to go do this tonight. Your bottleneck moves from memory to disk. The project's own documentation is refreshingly direct about this. Their compression feature exists specifically because, in their words, the bottleneck is mainly disk loading. That's the whole architecture in one sentence. You've traded a memory problem for an I/O problem, which means speed streaming. Experts from an SSD is orders of magnitude slower than reading from VRAM. This is not a conversational experience, and it is not a coding agent. It's a set it going and come back experience. If you've watched our expert streaming coverage before, this is the same trade at a larger scale. They do publish 2 mitigations, and both are honest and modest. There's an optional blockwise compression at 4 or 8 bits, which they say gives up to a 3x speedup with their phrase, almost ignorable accuracy loss. Note the clever detail. Because the bottleneck is loading rather than computing, they only need to compress the weights, not the activations, which is an easier problem than full quantization. And there's prefetching, which overlaps loading with compute for a further modest gain. And the setup honesty, because this is where evenings go to die. Their documentation lists 3 specific requirements for K3 support. 2 extra packages including flash attention, which K3's model code mandates regardless of what you request. A CUDA 12 build of Torch specifically because no pre-built flash attention wheel exists for CUDA 13 yet, and Transformers version 4.56 point something because K3's remote code does not load on 5.-X. Read that list again. 3 pin dependencies, one of which requires you to avoid the newest CUDA. That's not a criticism. It's normal for bleeding-edge model support, but it means this is a project evening, not a 5-minute install. There's also documented Mac support and CPU inference, which widens who can try it. Is streaming worth it for you? 5 honest questions. Before you spend a weekend on this, run these 5. I'd rather you skip it deliberately than abandon it at hour 3. 1. Do you actually want the output or the story? Both are legitimate. I ran the largest open model in the world on a 4GB card is a genuinely great sentence to be able to say, and hobby projects don't need to justify themselves. But if you needed an answer to a question, a hosted free route gets it to you in 90 seconds instead of a weekend. 2. Is your storage fast? The bottleneck is disk. A modern high-speed SSD makes this tolerable. A mechanical drive makes it theoretical. This is the one hardware upgrade that genuinely changes the experience. And notably, it's the cheapest component in the whole stack. 3. Can you tolerate pin dependencies? A specific CUDA version, a specific Transformers version, a mandatory attention package. If you have a working environment you rely on for other things, do this in an isolated environment rather than upgrading, or rather downgrading your main one. That's the mistake I'd most expect people to make. 4 is the task batchable. Streaming suits work you can start and walk away from. A long analysis, a document pass, a generation you'll read later. It's actively hostile to anything conversational or agentic where you're waiting on each turn. 5. Have you tried it hosted first? Cheapest possible experiment. Establish whether the model is even good for your work before you spend a weekend on the infrastructure to run it. It's a strange but reliable rule of this hobby. Test the model in the cloud, then decide whether it's worth the metal. If you answered yes to enough of those, you'll enjoy the project. If you flinched at 2 or 3, take the hosted route with a clear conscience. You're not missing much except the bragging rights, and I've just given you those for free. Free access compared, and the finding that decides this. Since local is genuinely hard for both, most of you will reach these models through hosted routes. So I did something specific before recording. I pulled the complete source of the open source routing gateway we've covered on this channel and searched its live free model catalog for both models. The result is lopsided, and I haven't seen it mentioned anywhere. DeepSeek V4 Flash, 8 separate free access entries. Its own first-party platform with a substantial starter credit, a major inference host, a monthly recurring allowance at another, a very large monthly allowance at a third, plus keyless options and aggregator routes. KIMI K3 1. A single provider with a one-time credit allowance. 8:1. If your practical question is which of these can I actually start using this afternoon without hardware, that ratio is the answer, and it isn't close. And there's a detail in that catalog I want to highlight because it's genuinely excellent practice. Each entry carries a terms of service tag. Some are marked as fine, several are marked caution, a couple are marked avoid, one is marked ambiguous. 2 things follow. First, the single route tagged as unambiguously fine for V4 Flash is the first-party one, DeepSeek's own platform. That's usually how it goes, and it's the route I'd point you at. Second, Even the routing infrastructure that exists purely to find you free capacity is flagging terms of service caution on most third-party pools. When the tooling built to get you free access is telling you to read the terms. And the standing caveat, free pools resize constantly. Verify current allowances on each provider's own page, rather than trusting any figure from a video, including this one. So which should you actually use? 5 honest cases. If you're on 8 to 24 gigabytes and want a daily driver, neither. Run a good 27 to 32 billion model locally and reach V4 Flash through a free hosted route for hard tasks. That combination costs nothing and covers the overwhelming majority of real work. And it's the 80-20 split we come back to every week. If you have 128 gigabytes or more, V4 Flash is your local flagship. Great ratio, big context, MIT license, and it runs fast once it fits. If you want K3 specifically, on consumer hardware, expert streaming is your only route, and go in knowing it's a weekend project with pin dependencies and seconds per token output. The payoff is real though. Actually running the largest open model in existence on a card that cost you a few $100s is a genuinely remarkable thing to have done. If you need enormous context, V4 Flash by a mile. A million token window is its differentiator. And if you just want to try both today for free, V4 Flash through its first-party platform and K3 through the single provider that carries it. Half an hour, no hardware, real answers. Head-to-head on the axes that actually matter. Let me put the whole comparison in one place, because a list of specifications isn't a decision. On raw size K3, by an order of magnitude, 2.8 trillion against 284 billion. Whether that matters to you is a different question entirely. And mostly it doesn't. Size is an input, not an outcome. On conventional local runnability, V4 Flash wins decisively. It's a workstation tier model. K3 isn't a consumer model at all on the standard approach. If you have serious hardware, this is not close. On streamability, K3 wins. And this is the genuine surprise of this video. Its extreme sparsity ratio is exactly what per expert streaming exploits, and the published figure, under 4 gigabytes, is the most striking number in this entire comparison. On context, V4 Flash with a million token window. That's a real differentiator for whole repository reasoning and long document work. On free access today, V4 Flash 8 routes to 1, not close. On licensing. Both are permissive and both are genuinely yours. V4 Flash under a straightforward MIT, K3 under a modified MIT. If you're building commercially, read K3's modifications rather than assuming modified is doing real work in that phrase, and it's a 2-minute read that could matter. On reliability. The reported hallucination figures don't flatter K3, worth weighing more heavily than any parameter count if you're shipping something. Add that up and the honest verdict splits cleanly. For actually getting work done at almost any hardware tier, V4 Flash is the practical answer. Better access, better context, reachable locally if you've invested in hardware. K3 is the more remarkable artifact and the better demonstration. The largest open model in existence, running on a card that costs less than a phone, because someone read the architecture and wrote a clever loader. Both of those are worth something. Just be clear with yourself about which one you're chasing on a given evening, the tool or the achievement. I've spent evenings on both and I regret neither, but I'd have been annoyed if I'd confused them. The honest limits 4. 1. I have not personally benchmarked either model. No scores in this video deliberately. What I've given you is architecture, arithmetic, and verified access, and the sources are linked so you can check every claim. 2. The streaming figures are the project's own published measurements. They're specific, they name the hardware, and the project is long-standing and open source. That's about as good as a vendor claim gets, but it is still a first-party number, and your results depend on your disk, your card, and your patience. Treat it as documented and plausible rather than independently confirmed. 3. Size is not quality. 2.8 trillion parameters is an astonishing engineering achievement and tells you very little about whether the output is right. That reported hallucination figure is the reminder for real work. Being wrong less often usually matters more than being clever more often. Test on your tasks. 4. All of this moves. Quantized community versions, distilled variants, provider price competition, better streaming. All of it arrives in the weeks after releases like these. And much of it will change the answers above. The method here outlasts the numbers. Find the total, find the active count, halve the total for the memory floor, then check whether Sparsity opens a streaming route. Step back, because there's something genuinely lovely in this comparison. For 2 years, the local AI story has been, models get bigger, your hardware doesn't, the gap widens. This is the first time I've been able to show you the opposite. The models got so sparse that they came back within reach. Not by shrinking, the weights are the full weights, but because a model where 2% is awake at a time doesn't need all of itself present at once. That's the pattern worth holding. The frontier of what's possible moves slowly. The frontier of what's possible on your machine is moving extremely fast. and it's moving because of architectural cleverness, not because anyone bought more RAM. And underneath it, the thing that makes any of it possible, both of these are open weights. Someone could read the architecture, notice the sparsity, and write a streaming loader. Nobody can do that for a model behind an API. The permission to look inside is what turned impossible into slow but working, which is the whole argument for open weights demonstrated rather than asserted. So here's my question, and I'll pin it below. Has anyone actually got K3 running via streaming, and what tokens per second did you see? The published figure is a memory number, not a speed number, and speed is what decides whether this is a party trick or a tool. If you've done it, post your hardware and your throughput. That's the independent data nobody has yet. And this comment section is genuinely the best place on the internet to collect it. And if you're on the workstation tier running V4 Flash locally, tell us how it feels day to day. Same reason. Every link, the streaming project with its published figures, both models' weights and licenses, the routing gateway I searched, and our hardware guide so you can place yourself on the tier list is in the description. Verify everything I've said. That's the entire point. That's the standard here. The real explanation, sourced in plain English with the arithmetic shown and the trade-offs named rather than skipped. If you'd rather own your tools than rent them, subscribe. That's what we do every single day. I'll see you in the next one.